বাড়ি শরীর ছাড় রাত্রে যারা যারা মিলে যাবে আমরা আমি যাবো কেউ যাবে না আমাদের
Good morning, everybody. Am I audible?
Yes, sir.
Okay, wait for 2 minutes, then we will start. So rest of the students could join. Okay, so let us start the class because I don't know when they will join or not join. So let us start the proceedings and then we will go for those who will come, then I will join them. So first of all, what is my request is that to everybody, because today we will go for the derivation. So everybody, I am asking everybody, do you know the two-port network, mesh network topology? I think everybody has learned these things in their network theorem or like that chapters. So today I will apply that theorem or that thing here to clarify the theorem that we are discussing in the last day. What was the theorem that was we are discussing in the last day? We are discussing about the reciprocity theorem. And in that reciprocity theorem, we have equivalent T network corresponding to the terminal network. And that 2T network will be now explained and proved. And that proof and explanation will be needed the mesh topology network, KVL and KVL applications. So everybody know that thing, KVL, Kirchhoff's voltage law?
Yes, sir.
Kirchhoff's mesh law, Kirchhoff's voltage law, that will be used here. So first let us start with the thing that is the two-port network or T network that we draw last day. From that network, we will just today produce everything. So yesterday, the equivalent T network was drawn. First of all, let me start with today is 8/1/2022, and today we are going to discuss the explanation of the reciprocity theorem and to prove the reciprocity theorem of antenna. And my name is Kaustukaldi Mondal. I'm from Dumka Engineering College, and we are here on the class of antenna and wave propagation. So today's date is 8/1/2022. Okay, so we'll discuss about the explanation of the reciprocity theorem. Explanation explanation of reciprocity theorem. We're going to discuss about this. So in that we have drawn the two equivalent T network corresponding to the terminal network, and that equivalent network we will draw it first and then we will discuss it. So let us draw it first. Just a minute. So you can see the whiteboard, it is clear. Everyone,
Yes, sir.
you can see the whiteboard.
Yes, sir.
Okay. So first let us draw the equivalent network. Yesterday we have drawn it, but today for your explanation, it is required, so I am drawing it again. So this is the equivalent network. This is Z11. This is Z12. Two impedance are there. This is the first port. So in between there is another impedance Zm. Okay, this side is the first terminal. So one, this is the one terminal. And here the impedance EMF value is E12, EMF induced. And here is the current induced, that is I2. Okay, so this is the second terminal. So this is mesh network 1, this is mesh network 2. We'll apply KVL mesh topology. The current is flowing this side. This is I1 current. And this side is the I2 current. Okay. Sorry, this is Z22, not 1, 2, Z22. So this is the terminal antenna 2. This is the terminal antenna 2. And this is the terminal antenna 1. Terminals of antenna 1. Now this is terminals of antenna 2. So this is the equivalent T network first, and another equivalent T network was this will be Z11. Okay. This will be Z22. This is here. This is another terminal. This is EMF induced is E of 21. Okay, this is the ZM. So this is one topology, and this is two, second topology. Here there is a current. This is I1. This current is flowing this side. This current is flowing this side. Terminal of antenna 1, and this is terminals of antenna 2. Okay. So clear about the drawing? No problem with the drawing? Am I audible?
Yes, sir.
Okay. So okay. So now the explanation. From the above figure, what we are taking, from the above figure, let number 1, a transmitter of frequency F and zero impedance be connected to the terminals of antenna number 2. So what we are doing, a transmitter of frequency F and zero impedance be connected to terminals number 2, in which which is generating a current I2 and inducing an EMF E12 at the open terminals of antenna number 1. So what we are taking, first possibility we are taking is that a transmitter of frequency F and zero impedance be connected to the terminals of antenna number 2 which is generating a current I2 and inducing an EMF and inducing an EMF E of 1 2 at the open terminals of antenna number 1. This is figure 1 and this is figure 2. Okay. Number 2 position is that now the same transmitter is transmitted transmitted, not transferred. FERR to antenna number 1 which is generating a current I1 and inducing a voltage V of 21, sorry, V not E of 21 at the open terminals of antenna number 2. In figure 2. Okay. So thus, according to the statement of reciprocity theorem, I1 equals to I2 provided E12 equals to E2. Okay. Is it clear to everybody? Are you listening, everybody?
Yes, sir. Yes, sir.
So, we can write what? We can write continued from the first. Since the ratio of an EMF to current is an impedance, therefore, the ratio E12 by I2 is given the name transfer impedance Z12 as in case of one, and so also the ratio E21 by I1 as transfer impedance Z21 as in case 2. Okay, understand? Understand? कोई जवाब नहीं. The ratio, hello, जो
Yes, sir.
जो बोल रहा हूं वो समझ पा रहे हो या डेरिवेशन है इसलिए पूछ रहा हूं.
Yes.
E1 to the current I2 is defined as just a minute. Just a second, sorry. So this is defined as transfer impedance ना डिस्टर्ब करता है ना सर. हाँ
बोलो।
हाँ, तो जो बोल रहा था वो है अपना जो ये होता है, ये इसको डिफाइन करते हैं हम लोग ट्रांसफर इम्पीडेंस के ऊपर, and it is represented as Z of t, or it is represented as Z of 1 2, that is Z of t equals to Z of 1 2 equals to E1 by I2. Thus, from reciprocity, it follows that 2 ratio, that is 2 impedance, denses are equal, are are equal. So that is Z of 1 2 equals to Z of 2 1, or it can be written as Z of M equals to Z of 1 2, that is equals to Z of 2 1 equals to E of 1 2 by I2 equals to E of 2 1 by I1, or it can be written as E of 1 2 by I1, sorry, I2 equals to E of 2 1 by Y1. So this is the reciprocity theorem. So clear, everybody? Yes, students? Clear?
Yes. Yes, sir.
So this proof is very much important. This is the explanation, and after this explanation, there is proof. So proof is same important as explanation. Okay, so please give your attendance because it is already time. 6 people are there, 5 people are there. Please give your attendance in the chat box. Everybody, please give your attendance. Type your name in the chat box. सबने दे दिया अटेंडेंस? ओके, अगर सबने दे दिया तो प्रूफ पे जाते हैं। इसका बहुत ही अच्छा तरह प्रूफ है। प्रूफ इजी है, आप लोगों को थोड़ा हिंट्स दे देता हूँ। क्या करेंगे? To prove the reciprocity theorem for antennas, the space between the antenna number 1 and antenna number 2 are replaced by network of linear passive and bilateral impedance shown in figure C and figure D. Corresponding the figure C and figure D, because any four terminal network can be converted into equivalent T network. That's why we have converted into T network. अंडरस्टैंड क्या बोल रहे हैं? ये टी नेटवर्क के बारे में बोल रहे हैं। ये देखिए, ये फिगर 1 एंड फिगर 2, these are nothing but the corresponding figure of फिगर सी एंड फिगर डी। फिगर सी फिगर डी कौन सा था? नो, लास्ट दिन मैंने जो ड्रॉ किया था उसका फिगर सी फिगर डी बोल रहे थे। तो आप लोग जानते हैं लास्ट दिन कौन फिगर सी फिगर डी के बारे में बात कर रहे थे? थोड़ा दिखा लेते हैं आपको जो कौन से बारे में बात कर रहे थे। एक मिनट रुकिए। हम इसके बारे में बात कर रहे थे। ये जो दो फिगर सी था ना, ये वाला फिगर सी, ये वाला फिगर डी, आप देख पा रहे हैं? स्क्रीन को देख पा रहे हैं?
Yes, sir.
तो ये दोनों फिगर को, ये जो पिंक कलर फिगर और ये जो मैजेंटा कलर फिगर है, इन दोनों को मैंने दो टी नेटवर्क में इक्विवेलेंट किया। एक वाला ये और एक वाला ये, जो आज भी हमने ड्रॉ किया था। ये वाला, ये वाला, ये दो। तो इन दोनों से हम लोग प्रूफ करेंगे ये रेसिप्रोसिटी थ्योरम। और यहाँ पर हमने क्या किया था? यहाँ पर हमने जो हमारा इम्पीडेंस था ना, उस इम्पीडेंस को हम लोग लिख लेंगे। जैसे कि हम लोग क्या करेंगे, Z11 इक्वल्स, और सॉरी इक्वल्स नॉट, कॉमा Z22, ये क्या करेंगे? These are self impedance antenna number 1 and antenna number 2, antenna number 1 and 2 and Zm क्या होगा? Zm होगा म्यूचुअल impedance between two antenna. Okay. Now 1,1 is terminals of antenna 1, and 2,2 is terminal of antenna number 2. Okay, now we will apply KVL, Kirchhoff mesh law, in figure C for loop 2 and loop 1, and we will get. But today we have no time, so we are not going to that KVL. We will